Hi, I'm from Kaijing and my metric number is ap200195. Today, I'm going to present about what is 3D printing. So, what is 3D printing? 3D printing is an additive process whereby layers of material are built up to create a 3D part. This is the opposite of subtractive manufacturing processes, where a final design is cut from a larger block of material. But today, I'm going to focus on selective laser sintering, which is a choices of the 3D printing. So, what is selective laser sintering? Selective laser sintering, also named as SLS, is a rapid prototyping technology that turns 3D CAD data into physical part in a matter of hours. Selective laser sintering, or SLS, is a rapid prototyping technology that turns 3D CAD data into physical part in a matter of hours. SLS is an additive manufacturing technology that uses powdered nylon 11, nylon 12, and PEEK materials. Parts produced are lightweight, highly durable, and both heat and chemical resistant, making SLS an excellent choice for producing production parts without the expenses of tooling. The SLS process begins by splitting 3D CAD data into the cross sections or layers. The data is then transferred to the SLS additive manufacturing equipment. The machine then begins to create the first layer. After a leveling roller spreads a thin layer of powdered material across the powder bed, a CO2 laser traces the cross-section of the material. As the laser scans the surface, material is heated and fused together. Once a single layer is complete, the powder bed is lowered to make room for the next layer. More material is introduced from the powder cartridge and rolled out smooth, while unused material is recycled. The process is repeated, building layer upon layer until the part is complete. As a SLS part are built, they are encompassed by unseen thread powder, which provides supplemental strength and eliminates the need for support structures. Complex designs and assemblies once thought impossible are now being redesigned with SLS as cost-effective integrated structures. Solid concepts manufactured parts utilizing nylon with property-enhancing fillers to create rugged SLS parts suitable for a variety of prototype and production applications. Typical use of SLS include tools and features, fuel tanks, flight-rated components for unmanned aerial vehicles, automotive designs, air ducts, architectural models, and artistic sculptures. Here, I'm going to present about the advantages and disadvantages of using selective laser sintering, SLS. So, they have 4 advantages and 4 disadvantages. First and foremost, for the advantages of SLS, it is not need for support. But for the disadvantage is, when the product shifting from MDM or SLA to SLS is very difficult. For the second advantage is, batch printing is easy, but the variety in the raw materials is limited. For the third advantages is very fast 3D printing. But for the disadvantages of using SLS is 3D printers are brittle in nature. And for the last advantages is the SLS is a best for experimental use, but it is potential health hazards. As the conclusion, selective laser sintering, or SLS, is a good invention for the future. This is because it can help us to create geometries in a short time and reduce many of the costs. Although it is good invention, but SLS also need to proceed in a proper way to prevent the criminal accident happen.